All right, found on page 285 is a list of communities. Their index of exposure is given, and the amount of cancer deaths that they experienced is also written there. The first column is always your X column. That will go into your list 1. See the other video if you need some help with the calculator, stat edit, list 1. In your second column is always your Y column, and that will go into list 2. Now, you run stat calculate lin regresh to get the Y equals equation. Y equals 9.27x plus 114. That can be used to figure out the predicted amount of cancer deaths that should have taken place. Now, before we do that, let's discuss the slope in context. Slope. When we talk slope in context, you're always talking about the x value increasing by 1. So as the index of exposure increases by 1, then you talk about the second column increasing by the slope. So then the deaths will increase by 9.27. And that's your slope in context answer. To get a predicted amount, say we wanted to do for when the exposure is 2.5, you just use your equation. So 9.27 multiplied by 2.5 plus 114, and that will give you your predicted amount of 137. Now, it could be a question that just asks for the predicted amount, or you might have to fill in this whole sum of squared residuals table. So to continue on with the table, you would do 9.27 times 2.6 plus 114 and get 138. Continue that procedure down, putting in the different x's, the different index of exposures, to get your predicted amounts of deaths. Okay, now that we have all of the predicted amount of deaths, we could calculate a residual or all of these residuals. So to calculate the residual, that is the difference between the actual amount of deaths that occurred in the community and the amount that is predicted by the linear equation. So 147 minus 137 will give you the residual for Umatilla. And 130 minus 138, which is negative 8, will give you the residual for the community Morrow. Now, if it's positive, then the actual point is above the line. If the residual is negative, the actual point is below the line. And the residual is the length or the distance between the point and your predicted line if you had a graph. Continue that procedure to fill in the residual column. Now, if the problem was asking you for the sum of squared errors or squared residuals, either one, for your predicted line, you would have to take these residuals and square them. And remember, when you are squaring something, you are multiplying it by itself, and a negative times a negative is a positive. So 10 times 10 is 100. Negative 8 times a negative 8 is 64. All right, now for 9.27x plus 114 to be our least squares regression line, the sum of the squared residuals or errors should be the smallest number if we have two lines to pick from. In this case, it's 1,396. And the sum of the residual column should equal 0. In this case, it equals 6, which is pretty close. It's probably just some rounding errors off of those predicted amounts, if you know what I mean. And you should also double check to make sure the centroid is on that equation. Okay, so to do the centroid, you are finding the average x and average y. If you don't know how to do that in the calculator, just go ahead and add up those column and then divide by how many there are, which is 9. If you have them in list 1, list 2, remember that you can do the yellow button, the second button, stat, go over to math, and sum is number 5. So it would add up the column for you. You have to put in list 1 after that, or list 2. For this particular problem, I got 4.6 for my first column and 157.4 for my second column. So that should be my centroid. Now, if that equation, y equals, is the least squared regression line, then that centroid should fit in it. So we check the y was 157.4, which should be equal to 9.27 times 4.6 plus 114. So 9.27 times 4.6 plus 114 is 156.6. So what with taking into the account of rounding, that is close enough to consider the centroid on the line of best fit.